It's given in 2015. And the question asked is to calculate A intersection B whole complement. You just need to convert them into list form. It's very clear that 0 is a root. If you take x square common here, x cube minus 6x square plus 11x minus 6 equal to 0. And x equal to 1, if you substitute, you get 12 minus 12, 0. So 1 is also a root. And in the options, what you can see, 2 you can see. So that's why it's better to verify 2 instead of worrying about solving it. You just substitute 2 in it and then check. You substitute 2 cube is 8 and 2 square 4, 4 6 are 24 plus 22 minus 6. So 30 minus 30. So that's also true. So 2 is another root. So you have only one more root for this equation. Most probably it should be 3. So 3 also verify and check. 27 minus 9, 54 plus 99 minus 6. 54.
So it's plus 33.
33 actually, 33, yeah, because it's only 3. So then this will be 50, 60, and this is also 60. So this is also satisfied. So this is just 3. So this universal set is that. And here sum of the roots is 5, product is 6, and 2 and 3 are the roots. So 2, 3 is this. And this is, I think, 1, 2 is this. So automatically A intersection B is just 2. Its complement means just eliminate 2, 0, 1, 3, and that's third option. So the given Z is equal to this and Z power 1 by 3 equal to this. They're asking the K value in one of the relation between XY and AB. So to get the relation between AB and XY, you need to eliminate Z from these two. That means if you take Z power 1 by 3, the whole cube equal to A minus IB the whole cube. So this is basically Z. This is A cube minus 3A square IB plus 3A IB the whole square minus IB the whole cube. So Z is X plus IY equal to A cube minus 3AB square plus I into minus 3A square B, and then this is I cube is minus A minus plus B cube I taken common. So this is what you get. So you get X equal to X by A. Directly you get equal to A taken common. It's A square minus 3B square. Similarly, Y by B equal to the B square minus 3A square. So the X by A minus Y by B equal to A square minus 3B square minus B square plus 3A square, which is equal to 4A square minus B square. So 4A square minus 4B square 4. So the K equal to 4. That's fourth option. A simple simplification. I power 4 multiple is always 1. So the nearest 4 multiple is 56. So I power 56 into I plus 1 by, I think it's better to multiply with I power 3 in numerator and denominator, so that directly denominator will get I power 4 multiple 28. So which is equal to, this is 1 and this is 1. And this is I. And I cube is minus I is a well-known fact for us. So 0 is the answer. F of x equal to ax square plus bx plus c. Both roots are more than k. Here k is a real number. You can compare the roots with the real number only if the roots are real numbers. Suppose imaginary roots I and all involved in the roots, then you can't say that both the roots are more than k and all. That's why the first condition is the delta should be greater than or equal to 0. Then only two real roots will be there. So when the two real roots are there, let the roots be alpha, beta. When you're letting the roots as alpha, beta, so automatically ax square plus bx plus c, which is f of x, should be equal to a times x minus alpha into x minus beta, because you're calling alpha beta as roots. So this quadratic polynomial should be factorized into a times x minus alpha into x minus beta. Then f of x by a is equal to x minus alpha into x minus beta. So now we are trying to find the condition for both the roots to be more than k. So for both roots to be more than k, um, uh, k minus alpha and k minus beta both should be negative numbers, because k is less than both alpha and beta. So k minus alpha, k minus beta both should be lesser numbers, so negative numbers. So this should be negative and this should be negative for x equal to k. So for x is equal to k, these two are negative, the product is positive. So the f of k by a is nothing but k minus alpha into k minus beta. This should be greater than 0. But the problem is, even k lies on the right side here, still both will be positive and then the fraction would be positive. So you get the same condition. These two conditions you get the same for both the roots less than k also, you get the same. But if you see, this is the line of symmetry, x is equal to minus b by 2a. If k value is less than minus b by 2a, along with these two conditions, then both roots will be greater than k. Suppose instead of this, if you got minus b by 2a is less than k along with these two conditions, then you get both roots less than k, right? So this is the logic behind that. So this and all is the concept. Now we'll apply the concept for this particular problem. For this particular problem, they are given the k as a. So you need to be careful with the formula and the particular problem given. In general, in formula, a is x square coefficient, but here a is given for some other purpose. A is given as a c. At the same time, same a is used as k also. So you need to be careful. And so your k is a, and your equation is like this. And we need not to worry about the alpha beta, finding alpha beta or something, because we have conditions used one by one. So for this d greater than or equal to 0, d is b square minus 4ac. So the minus 1, no, plus 1 whole square minus 4 into a is 1 and c is a greater than or equal to 0. So 1 is greater than or equal to 4a. 1 by 4 is greater than or equal to a. And then the next condition is f of k by a greater than 0. K is a for us. So you substitute a in place of that. So a square plus a, and already one a is there. This is f of k by a. But this a is x square coefficient, which is 1, is greater than 0. So a square plus 2a. So a into a plus 2 greater than 0. So that minus 2.
So from the first condition, you can directly say that it's the fourth option, right?
Okay. If you use elimination, maybe you can. So it should be less than 1 by 4. A should be less than 1 by 4, and this doesn't agree with that. This doesn't agree with that. And yeah, even this doesn't agree with that. A should be less than 1 by 4. Okay, okay. So you're getting values which are more than 1 by 4 in all these three cases. So definitely it should be fourth option. Okay. So using elimination, we can get it, but like let us see the general process. If the options are not in favor of us, then what to do and all we just see. So the a square coefficient is positive. So plus minus plus, we want the product to be positive. So it's minus infinity to minus 2 union 0 to infinity. So now along with this condition and this condition, a should be less than 1 by 4 means These two, if you include, the intersection is minus infinity to minus 2, union 0 to 1 by 4, closed. Now, one more condition, the third condition. What is that? Minus b by 2a. Minus b is minus 1 by 2. A is 1. A is minus b by 2 is greater than k. K is what? K is a itself. So a should be less than minus 1 by 2. So a should be less than minus 1 by 2 means this is gone. This part cannot be present if you include this condition also. So finally, you'll remain with minus infinity to minus 2. So that is fourth option. Yeah. They want the locus of z where the real part of this is equal to 4. So first z bar is x minus iy plus 2 by x minus iy minus 1 equal to x plus 2 minus iy by x minus 1 minus iy. So into you to get the real part of this, you need to multiply the denominator with its conjugate x minus 1 plus iy by x minus 1 plus iy. So then it will be x plus 2 into x minus 1, x plus 2 into x minus 1, and plus x plus 2 into iy minus x minus 1 into iy. First into first, first into second, second into first, second into second. Minus I square is plus y square by x minus 1 the whole square plus y square. So the real part is equal to 4. So the real part is basically this and this. So x plus 2, okay, let us open the bracket instead of leaving x square minus x plus 2x, which is plus x minus 2 plus y square by x square minus 2x plus 1 plus y square equal to 4. So this is x square plus x minus 2 plus y square equal to 4x square minus 4 to the 8x plus 4 plus 4y square. So you send everything to the RHS, 3x square plus 3y square minus 9x plus 6 equal to 0. So it's basically a circle equation. You can take the 3 common also. I think x square plus y square minus 3x plus 2 equal to 0. Yeah, maybe you get a circle equation. What they're asking? Is the straight line parallel to x-axis? Wrong. Straight line equally inclined to the axis? Wrong. A circle with radius 2 and a circle with radius half. We have a formula for radius under root g square plus f square minus c. Basically, g is 2g is x coefficient. G is minus 3 by 2. So whole square is 9 by 4. And minus f is 0, c is 2. So it's root 1 by 4, which is 1 by 2. So circle with radius 1 by 2 is the correct option. That is option 4. So they're given alpha, beta are the roots of this equation. They're asking us to find the equation with the roots alpha power 100 and beta power 100. So in general, we'll be worried about finding the roots and then getting this. But we know that omega and omega square are roots of x square plus x plus 1 equal to 0. But if you observe this equation closely, this is minus x plus minus x whole square plus minus x plus 1 equal to 0. So in place of x, you have minus x. So If you take this as an equation in minus x, so minus x equal to omega and omega square. So omega and omega square will satisfy in place of minus x. So that means in place of x, minus omega and minus omega square will satisfy. So the roots are, okay, if, because we are naming the roots as alpha and beta. So the alpha equal to minus omega and beta equal to minus omega square. So the alpha power 100, because the power is even, the minus power even is minus, omega power 100, which is equal to omega power, any 3 multiple is 1, omega cube is 1. So it becomes omega again. And beta power 100 equal to the omega minus power even number again plus, and then 200. So the omega power 190, 98 is the 3 multiple. 198 if you remove, then omega square it becomes. So the omega and omega square. So alpha power 100 is omega, beta power 100 is omega square. Equation with omega and omega square as roots is a well-known equation for us. The answer is x square plus x plus 1, which is there in the option 4. About omega, so cube roots of 1. Cube roots of 1 means roots of x cube equal to 1. So to find the roots of x cube equal to 1, x cube minus 1 equal to 0. That implies using a cube minus b cube formula, x minus 1 into x square plus 1 square plus x into 1 equal to 0. That implies x equal to 1 and x square plus x plus 1 equal to 0. So to solve this equation, x square plus x plus 1 equal to 0, use the quadratic formula, x is equal to minus 1 plus minus root of b square minus 4ac, 4 into 1 into 1 by 2a. 2a is 2 into 1, 2. Now this is minus 1 plus minus root 3i by 2. So the first root is named as omega. Omega is equal to minus 1 plus root 3i by 2. So the minus 1 by plus I minus 1 plus I root 3 by 2 is named as omega. But like if strangely if you square this, you get minus 1 minus root 3i by 2. So that's why instead of giving separate name for the second one, you write the second one as omega square itself. Minus 1 minus root 3i by 2. So this is omega and this is omega square. And if you observe carefully, like omega is obtained from this equation. So omega is a root of this equation. So omega should satisfy this equation. So the omega square plus omega plus 1 equal to 0. That's how we got the property omega plus omega square plus 1 equal to 0. At the same time, the omega is also a root for the mother equation, this one. So omega is a root for the main equation also. So you calculate omega cube, and that should satisfy omega cube x cube minus 1 equal to 0. So omega cube minus 1 equal to 0, omega cube is equal to 1. So that's how we got these properties we use frequently. Now for this equation, omega, omega square are the roots. And here, this is a kind of t square plus t plus 1 equal to 0. Then t equal to omega and omega square are the roots of this equation. That's what we're doing. So the t is minus x. So the t equal to omega and omega square, because it is t square plus t plus 1. But what we did a substitution minus x equal to t. So write at t equal to minus x reverse. So then you get x equal to minus omega and minus omega square. Then you understood that minus omega and minus omega square are the roots of this equation. So alpha is minus omega, beta is minus omega square. And used those, and then we got the values of alpha power 100 and beta power 100 as omega omega square using these properties which we derived just now. And that's it. Next, the amplitude of a complex number. If z is written in the form of r into cos theta plus I sin theta, which is called polar form, or r into e power I theta, which is Euler form, then the amplitude of z or argument of z equal to the theta. First, you should get that into this form. So now you should convert this complex number into that form. For that, sine pi by 8 can be written as 2 sine pi by 10 cos pi by 10 plus I into 1 minus cos a is 2. This I use the formula sine a equal to 2 sine a by 2 cos a by 2. Sine a equal to 2 sine a by 2 cos a by 2. That's the formula I use for this. Now I'm going to use this formula 1 minus cos a equal to 2 sine square a by 2. If you use that formula, this is 2 times of sine square pi by 10. Now the 2 sine pi by 10 is common. So you remain with cos pi by 10 plus I sine pi by 10. So it's very clear that the R is 2 sine pi by 10 and the argument or amplitude, or they give the name for the complex number, whatever it is, this complex number, argument of it is just pi by 10, and that's the answer. X equal to omega minus omega square minus 2. They're asking us to find the value of this. Directly substituting x value in this and calculating is lengthy. That's why what we'll do is we'll try to write this, get into one side and try to eliminate I from it. How to eliminate I from it means you can bring the minus 2 to this side. This becomes x plus 2 equal to omega is minus 1 plus root 3I by 2 minus omega square is minus 1 minus root 3I by 2. We know this very well. I mean, you can even go keep this in terms of omega and do the calculation because we know the values of it, value of it, and then it is easy to cancel this minus 1 by 2, and this will be plus 1 by 2 cancel. Then this will be root 3 by I by 2, and then root 3I by 2 times. So this becomes root 3I. Otherwise, you keep that as omega minus omega square and square on both sides also. No worries, that is also fine. Now squaring on both sides will help us to eliminate this I. So this is x square plus 4x plus 4 equal to 3I square, which is minus 3. So the x square plus 4x plus 7 equal to 0. Call that as equation 1. Now, using this equation, we'll try to get all these terms which are there in the required expression. So we need x power 4 and we have x square. So multiply the equation 1 with x square. Then you get x power 4 plus 4x cube plus 7x square equal to 0. Now we want 3x cube, but we have 4x cube. So we need to get minus x cube. So how to produce minus x cube from this? Multiply with minus x. So then you get minus x cube and then minus 4x square minus 7x equal to 0. Now if you observe the x square term, we have 3x square by adding these two, but we need 2x square. So one excess x square is there, we need minus x square. So multiply this with minus 1. So this minus x square minus 4x minus 7 equal to 0. And then this is minus 11x is also there, but we want minus 7, we have we need minus 6, we have minus 7. That's okay, we can adjust that. So x power 4 minus plus 3x cube, and here it is what as we need plus 2x square minus 11x minus 7 is there. Minus 7 can be written as minus 6 plus 1. Sorry, minus 6 minus 1 equal to 0. But we want only this expression. So obviously that expression will be equal to plus 1. And that is the first option. They're given alpha, beta are the roots of this equation. So that means if the coefficients are A, B, C, then alpha, beta are the roots of that equation. They're asking us to find the roots of this equation. This also, you can divide the entire equation with x plus 1 the whole square. Then this becomes a into x by x plus 1 the whole square plus b into x by x plus 1 plus c equal to 0. like we did in one of the previous problems. If you put x by x plus 1 equal to t, then this is at square plus bt plus c equal to 0. So we already have that alpha beta are the roots of this equation. That means x equal to alpha and x equal to beta are the roots of this equation. That implies t equal to alpha and t equal to beta are the roots of this equation. But what is t? T is nothing but x by x plus 1 equal to alpha and x by x plus 1 equal to beta. But we call the x value that satisfies this equation as the root of this equation, not the x by x plus value, x plus 1 value. So from this, we need to try to get the x value as a subject, x as a subject. To get x as a subject, you take the reciprocal of it, x plus 1 by x equal to 1 by alpha, x plus 1 by x equal to 1 by beta. And you separate it. So 1 plus 1 by x equal to 1 by alpha, 1 plus 1 by x equal to 1 by beta. So now we are almost there. 1 by x equal to 1 by alpha minus 1. So 1 by alpha minus 1 is 1 minus alpha by alpha. And 1 by x equal to 1 minus beta by beta. So automatically you end up with x equal to alpha by 1 minus alpha and x equal to beta by 1 minus beta, which is nothing but the fourth option. So why, after looking at this equation and to get that into the form of ax square plus bx plus c, we divide the entire equation with x plus 1 the whole square throughout that equation. Then we get this equation straight away. They are only given that z equal to a plus 2i and a is a positive value. They are given this relation satisfied by z. If you substitute that z a plus 2i, so if you take this z common, a plus 2i into mod z minus a. Mod z is under root a square plus 4 minus a plus 1 are equal to minus 1. Now if you equate the real part and imaginary part 2 into this equal to 0. Real part a into this is equal to minus 1. A into root of a square minus 4 minus a equal to minus 1. 2 into root of a square plus 4 minus a equal to 0. It's not like one of those need to be true. Both of them need to be true. So if you simplify this, root a square plus 4 equal to a. So a square plus 4 equal to a square, which will never happen. So we need not worry about whether it's going to happen or not. This itself is not happening. So there is no such complex number exists. So the roots of the equation means usually you'll find the roots, but the options are given about the nature of the roots of the equation. It is enough to find the d discriminant b square minus 4ac minus 2 root 2 the whole square minus 4 into a1 and c1, which is equal to 4 into 2 8 minus 4, which is 4, which is a perfect square. So delta is the d is a perfect square and moreover positive one. If you look at the options, first one is real and different. Yeah, they are real and different. That's correct. But let us see the other options also. Imaginary and different, second option, wrong. Third option, real and equal. Real and equal is also wrong. It will happen only if the d is 0. That's also wrong. And the fourth option, rational and different. So that's why we should not confirm blindly that real and different. We don't know whether they are rational or not. So we just see. Let us calculate the roots. So x equal to minus b. Minus b means 2 root 2 plus minus d. d is 4 by 2a2. So this is root 2 plus minus 2. So 2 plus root 2 or 2 minus root 2 are like root 2 minus 2. They are not rational numbers. So that is why it is cancelled and the real or different. So you need to be careful in these kind of options. Suppose if you get 2 and then 5 are as roots, even though real and different is correct, rational and different is a more accurate one because you should give as much as information as possible. So they are given this a plus ib equal to 1 minus I alpha by 1 plus I alpha. They're asking a square plus b square. So just take the modulus on both sides. 1 minus I alpha by 1 plus I alpha equal to mod a plus ib. So mod z1 by z is mod z1 by mod z2. So the mod z1 is the root of 1 plus alpha square. And mod z is root of 1 plus alpha square. This is root of a square plus b square. This is 1. 1 equal to root a square plus b square, or even a square plus b square is also 1. And that's the answer. They told that these two are having a common factor. We have a condition for two equations have a common factor. So a1x square plus b1x plus c1 equal to 0. Or like when you're calling a factor, just write it as a polynomial. a2x square plus b2x plus c2. If you write equal to 0, then we call the common root. Have common factor. Then c1a2 minus a1c2 the whole square equal to a1b2 minus b1a2 into b1c2 minus c1b2. And then, yeah, this is the formula. You can use this formula and then directly get a equation in A and then get the A value. Or like if you don't know the formula, forgot the formula, you can use the method which we use it to derive this formula. That is, let alpha be the common root. Then alpha square minus 11 alpha plus A equal to 0. And alpha square minus 14 alpha plus 2A equal to 0. So there is a method called cross multiplication method. Minus 11 minus 14, the alpha coefficients, constant terms, and then alpha square coefficients, and again alpha coefficients, minus 11 minus 14. And this is alpha square, alpha, and then 1. And then alpha square by minus 22a minus plus 14a equal to alpha by a minus 2a equal to 1 by minus 14 plus 11. So you just equate this alpha square and then alpha values. You get this alpha square equal to, this is 6 and 2, 8 minus 8 alpha minus 8a by minus 3. Alpha equal to minus a by minus 3. So then you have to eliminate the alpha. So the alpha square, a square by 9 equal to 8a by 3. So a equal to 0 is one possibility, but they given a not equal to 0. So other possibility is a not equal to 0. So that's why you cancel a on both sides. And this is 3. A is equal to 24. So when a is equal to 24, then you get the equations. X square minus 11x plus 24 equal to 0. X square minus 14x plus 48 equal to 0. So the two equations, the common root we need to find out. Yeah, see, actually we have options 3, 6, 8. We can verify these options. If none of them are common root, then we can take none of these as the answer. So if you see that 3 11s are 33, 3 square 9, 9 and then 24, 33. So 3 satisfies this. If 3 satisfies this also, then it's fine. This is a 9, 48 and then 9, 57. And then 3 14s are 12. Oh, it's not satisfying. No? So 3 is a root for the first, but not for the second. 3 is a 9. 3 14s are 52, but it is 57. So not matching. So then go for the next 6. 6 square. Okay. 3 is one of the root. So product of the roots is 24. 6 is the other root for this, obviously. So 6 is the other root. 3, 6. No. So 8, sorry. 8 should be the other root for this. So 8 satisfies this or not, that you check. 8 squared 64 minus 8 14s are what? 1, this is 48. Satisfying. So x minus a is a common factor for both of them. For this equation, they are given the product of the roots is 0. They're asking us to find the sum of the roots. So first we need to convert this into quadratic equation. X plus b minus x minus a by x plus a into x plus b equal to 1 by x plus c. X get cancelled. So b minus a into x plus c equal to x square plus a plus b into x plus ab. So we bring this to the RHS. X square plus a plus b, and this b minus a becomes a minus b plus a minus b into x plus ab, and this will be plus minus c into b minus a equal to 0. So this is anyway 2a, sum of the rows. What they are given? Product is 0, they are given. So product is 0, they are given means AB minus BC plus AC equal to 0. So A taken common, B plus C equal to BC. So A equal to BC by B plus C. But the sum of the roots equal to minus x coefficient by x square coefficients minus 2a by 1 minus 2a, but a is obtained as 2bc by b plus c minus 2 times bc by b plus c, which is there in both options. They are given argument of z1 bar equal to argument of z2. So suppose this is z1. Z1 bar will be here. So z2 is also should have the same argument of z1 bar. So that means z2 should lie on this line somewhere. So the z2 argument is same. The relation between z1 and z2. They are asking z1 and z2 relation. 1 by z1, if you take 1 by z1's argument, 1 by z1, suppose z1 equal to r e power I theta, 1 by z1 equal to 1 by r e power I theta in the denominator, e power I minus theta. So 1 by z magnitude may not be same as, may not be what, like it's not same, because Z's argument is R, sorry, Z's magnitude is R, Z1's magnitude is R, 1 by Z1's magnitude is 1 by R. So the 1 by Z1's, the argument of 1 by Z1 is minus theta. So it's the same as the Z1 bar. So the 1 by Z1 should be somewhere here, like this. So the 1 by Z1 and Z1 bar will have the same argument. They are given that Z1 bar and Z have the same argument. So obviously 1 by Z1 and Z2 will have the same argument. So they have the difference only in the magnitude. They have the difference only in the magnitude. Now if you see in this, then automatically Z2 should be equal to some constant times of 1 by Z1, because the argument is same, only difference is in the magnitude. So suppose Z2 is some R2 e power I theta 2 or theta, okay, theta 2, then the 1 by Z1 is also a constant times of that, like just what, how to say that, yeah. If we take 1 by Z1, 1 by Z1 equal to some um, R already used for Z1, okay, some P e power I alpha, something, some complex number. Then Z2 should be equal to, so we start from Z1 by Z1, then it is easy. So the Z2 should be equal to, in the diagram also you can understand that. So the Z2 is, Z2's argument is also alpha only, but the magnitude is not P, something else, some number should be multiplied. So assume that Q is multiplied, then Q times of P e power I alpha, if you multiply the argument modulus with Q, then you get Z2. So basically what you are getting, the Z2 equal to some Q times Z1 power minus 1, which is this. So instead of Q, you write K. You can write any arbitrary constant. So that should be the first option. A, B, C are real numbers, and ax square plus bx plus c has two negative roots. That means both the roots are less than 0. You can take the k is equal to 0, and then both roots, the condition, the three conditions we can apply. But instead of applying the three conditions, because that k value is 0, we can take that advantage. And when both roots are negative, that sum of the roots is negative, minus b by a should be negative, and the product of the roots is negative. So that means c by a is, the product of the roots is positive, sorry. So the c by a is positive. So with this, can we get some information? Yeah, because with this, we are not getting exactly which one is positive, which one is negative, but we know that A, C are of same sign, and because B by A, minus B by A is negative, so the B by A is also positive, and product of it is also positive. So both, so AC are also, AB are also same sign. So basically, you got all ABC are of same sign. Let us see any option says that. Yes, we have first option like that. What first option says is ABC are of same sign. Second option, A and minus B and C are of same sign. Third option says AB and minus C are of same sign. And fourth option says that A minus C are of same sign. So out of those, we can pick that first option, ABC are of same sign. When they told that mod Z1 by Z2 equal to 1, the mod Z1 by mod Z2 equal to 1, that implies mod Z1 equal to mod Z2. So that, let the equal magnitude be R. So let the arguments of them, let assume that they have a different argument, and that is theta 1, theta 2. Then what is the relation between them? You can improve this information. Argument of Z1 plus argument of Z2 equal to 0. That means one is a negative of another. So their magnitudes are same, and one is the negative of another. Their magnitudes are same, and one is a negative of another. Then what is the meaning of it? So one number's argument is the negative of another. So that means this is Z1, suppose. Its argument is theta, and Z2's argument should be minus theta. So Z2 can be anywhere on this line in general, only if you consider this condition. Z2 can be here or here or here. But if you look at this condition, the magnitude should be the same. So Z2 must lie here only, such that the magnitude of the length of that line from origin to that point, or the magnitude of Z2 is also same as that. That means basically Z2 is the conjugate of Z1. When they both are conjugates of each other, so their product is the square of its modulus. So the Z1 into Z1 bar is mod Z1 square. This is the property. A complex number into its conjugate is square of its uh, magnitude. And then, in fact, it is equal to Z1's conjugate magnitude square also, because the conjugate's magnitude and its magnitude are same. Now we got that Z1 bar is equal to Z2. We substitute that in it. Z1, Z2 equal to, and we consider only these two, mod Z2 square. See, the same property you can write in 10 different ways, but the way in which in options it's present is this. That's why we manipulated and then wrote that in this form. Otherwise, in this form, any other form is also possible. They're given Z equal to this, and they're asking the argument of Zi. For finding the argument of Zi, it's not required to calculate Zi actually. If you find the argument of Zi will be pi by 2 more than that. We already discussed a similar question here. Suppose this is Z. When you multiply the Z with I, so that will come here. The magnitude will remain the same, only the argument will be increased by pi by 2. So that's why let us simplify this one. So if we do the cross multiplication, 2, 2, 3 is 6, minus 3i minus 2i minus 5i, minus and minus plus I square is minus 1, plus 3 2 is 6, 2i plus 3i is 5i, plus I square is minus 1, by 2 square plus 1 square, 4 plus 1, a square plus b square, 5i and 5i get cancelled, and this is 6 plus 6, 12 minus 2, 10, 10 by 5 is 2, so Z equal to 2. Z is equal to 2 is a purely real number, and 2i is a complex number which lies on positive y-axis. So the argument of this equal to straight away pi by 2, and it is there in the fourth option. So the question asked is to find the value of it. We have the short form of the cos theta plus I sin theta as a cis theta. And with this short forms, we have formulas. Cis theta 1 into cis theta 2 equal to cis of theta 1 plus theta 2. At the same time, the cis theta 1 by cis theta 2 is the cis of theta 1 minus theta 2. So you can use this formula. So of course, the De Mor's theorem. De Mor's theorem is cis theta the whole power n equal to cis n theta. The evidence for all these is the Euler's form. If you write this in the Euler's form, so cis theta 1, if you write in the Euler's form, this is e power I theta 1 into e power I theta 2. So then it is e power I theta 1 plus theta 2. And if you write this back in cis form, then you get this. Similarly, you can get the evidence for these two also. Now, using those properties, you can write this as cis theta whole power 4 is cis 4 theta using the De Mor's theorem. And the denominator is cis of minus 3 theta. Yeah, This cis of minus theta is nothing but cos theta minus I sin theta. In middle, if you have minus, then that is cis of minus theta. So and this becomes a cis of 4 theta minus of minus 3 theta, which is equal to cis of 7 theta, and it is there in the option 2. Of course, they are written that in the form of cos theta plus I sin theta. They are written that as cos 7 theta plus I sin 7 theta. So they are given this is in 2007, and the previous one also 2007. They are given the roots of this equation are real and differ by at most 2m. So let alpha beta be the roots of this equation. So the difference of alpha beta is maximum 2m is what they're given. But you don't have the information about alpha minus beta, but you do have the information about alpha plus beta and alpha beta, because sum of the roots is minus 2a, and then the product of the roots alpha beta is plus b. So if you try to convert this into in terms of that, so because this is a non-negative value and the 2m is more than that, automatically the 2m is also a positive value. For positive value, squaring on both sides is allowed. I mean, both are positive values. So then it will be alpha minus beta the whole square. Alpha minus beta the whole square is alpha plus beta the whole square minus 4 alpha beta less than or equal to 4m square. Alpha plus beta is 2 minus 2a whole square, the 4a square minus 4 into alpha beta is b, is less than or equal to 4m square. 4 common cancel. So a square minus m square is less than or equal to b. So they're asking about the interval in which the b lies in the interval. So they told that the real roots. So for the roots to be real, d should be greater than or equal to 0. The 2a the whole square minus 4 into 1 into b should be greater than or equal to 0. Real and differ by at most of them. That implies real and it will be different and differ by at most 2 are real. Check with the person. So because they differ by 2m and then m not equal to 0, the difference cannot be 0. So the alpha should be different from b. So then this should be greater than only, not be greater than or equal to. So it's greater than. Then 4 can cancel. A square is greater than b. So that means b is greater than a square. So if you club these two equations, the b belongs to a square minus m square and a square. And this is the option, second option. Again, this location of roots with respect to a constant. Both roots are negative. That means both roots are like this. We can use that formula. What is that? The d should be greater than or equal to 0, and f of k by a should be greater than 0, and both roots are less than that, so the minus b by 2a should be less than k. So these three formulas we can use, or because it is 0, you can write sum of the roots greater than 0. What is that? Both are negative. Sum of the roots are less than 0, and the product of the roots greater than 0. If you do that, still you get these two conditions only. So if it is not negative, it is both the roots are less than 5 or less than 10 or less than minus 6 or something, some other number, then we must depend on this. Because they both are negative, we can either depend on this or directly write the first condition 2 times k plus 1 the whole square minus 4 into 1 into 9k minus 5 should be greater than or equal to 0. If you simplify this 4, 4 it cancel. K square plus 2k plus 1 minus 9k minus plus 5 is greater than or equal to 0. So the k square minus 7k plus 6 greater than or equal to 0. So k minus 1 into k minus 6 greater than or equal to 0. And the 1 and then 6. And then this is positive, rightmost positive, negative, positive. We want the product to be positive. So k belongs to minus infinity to 1 union 6 to infinity. But this is not the only condition. We have the second condition. Uh, if you take the product of the roots positive or f of k by a greater than 0, you get the same condition. 9k minus 5 is greater than 0. So the k greater than 5 by 9. So when you get k greater than 5 by 9, so this should be eliminated. So if you take the intersection of these two conditions, this all this interval goes, and as of now this is this, but this is not the final one. You should check the next condition also, which is minus b by 2a is less than k, or sum of the roots less than 0. Both are same actually. So minus 2 times of k plus 1 by 1 is um, less than k. K is 0 actually, or like both roots are negative means sum of the roots negative. So the k plus 1 is greater than 0, k greater than minus 1. So all the numbers in 6 to infinity are greater than minus 1. So there is nothing removed from this due to the extra condition. So the final answer stays as 6 to infinity and k greater than or equal to 6. That's the answer. They're given alpha, beta are the roots of this equation. Automatically alpha plus beta equal to minus t, alpha beta equal to q. Now you need to find the value of this. Omega alpha, if you open the bracket, directly let us open the bracket. Omega alpha into omega square alpha, omega cube alpha square, plus omega into omega omega square alpha beta, plus omega square omega square beta omega square alpha is omega power 4 alpha beta, plus omega square into omega omega cube into beta square. So the omega cube is 1 alpha square, and then omega square, let it be omega square, and omega power 4 is omega plus omega alpha beta. Omega cube is 1, so beta square. So alpha square plus beta square can be written as alpha plus beta the whole square minus 2 alpha beta, because we know alpha beta and alpha plus beta. So the unknown alpha square plus beta square is written in terms of known alpha plus beta and alpha beta, and plus alpha beta if you take common, you get omega square plus omega. We know that 1 plus omega square is 0. So omega plus omega square is minus 1. So basically it's alpha plus beta the whole square minus 2 alpha beta minus 3 alpha beta. So alpha plus beta the whole square equal to alpha plus beta the whole square equal to the t square. Minus t square is t square minus 3 into alpha beta is q. T square minus 3q. So the t square minus q. No, sorry. This is t square minus 3q. We have a triangular inequality mod z1 plus mod z2 is greater than or equal to mod of z1 plus z2. So it's straightforward from the triangular inequality in a triangle. In any triangle, sum of the lengths of two sides is more than the length of the third side. And if they are equal, then the 3 points are collinear, they won't form a triangle. So if you try to use that formula, So why we are thinking about that formula means inside one is z and one is z minus I. So you take the I minus z. So this value is equal to mod z plus mod I minus z. So now this is a sum of lengths of like the two sides of
So then there should be an equal sign, right?
yeah, equal sign is written here. So because we didn't confirm that Z1, Z2 uh, and Z1 plus Z2 are not collinear. We didn't confirm. We are taking Z1, Z2 as any complex numbers. So
Okay, fine, yeah.
Z1 can be here and Z2 can be here. So in that case, the equality holds. Suppose Z2 is not on the line of origin and Z1. So Z2 is here somewhere. Then they'll form a triangle. If Z1 and Z2 are collinear with origin, then they won't form a triangle. Okay. It doesn't matter for us. We don't need the two-place split and all. We directly write the sum is greater than or equal to the modulus of sum of these two complex numbers, which is Z plus I minus Z. So which is modulus of this. So the Z plus mod I minus Z is greater than or equal modulus of I is 1. So the minimum value of this is equal to 1 and it is given in the option 2. To find the number of real roots, let us try to solve this by putting x plus 1 by x equal to t. That implies t cube plus t equal to 0. That implies t into t square plus 1 equal to 0. That implies t equal to 0 or t square plus 1 equal to 0. That means t is x plus 1 by x equal to 0, x plus 1 by x the whole square plus 1 equal to 0. X plus 1 by x equal to 0 is never possible. Never possible in the sense, if you take x equal to I, then it is possible. I plus 1 by I is 0 only. But there is no real number satisfying this. If you got x square plus 1 by x equal to 0, x equal to plus minus I will satisfy this. But real numbers, real roots are not there. And coming to this, x plus 1 by x, the whole square equal to minus 1. So basically x plus 1 by x equal to plus minus, what is that square root, plus minus I. So again the same logic, x square plus 1 equal to the plus minus ix. So again the same logic, x square plus minus ix plus 1 equal to 0. If you use the quadratic formula, even for this also you won't get real roots. We are not interested in the roots of this. We are interested whether the roots are real or not. I still have a doubt, you just can go for that minus b plus minus formula. So the minus b means minus of plus minus I. Basically, you get four roots at the end. Plus minus I, uh, plus minus here again. B square, I square is minus 1. Minus 4 is 4 into 1 into 1 by 2a, the 2 times of that. So this is minus plus I plus minus, this is minus 4, so minus 5. So root 5I by 2. So it's again a complex, four complex roots you get. So all are complex roots. 6 roots are there for this equation. All 6 are complex roots. So the number of real roots of this equation is 0. So answer 0, option 1.